Welcome to Lab 1 of Physics 2212, Charged Tapes. So a little introduction here. Well, our purpose was to create two pieces of charged tape. We wanted to observe the interactions between the charged tape and other objects, calculate the electric charge of the tape, and simulate this using VPython. So a little results preview. We got the charge on the tape is positive, and that means both tapes are deficient in electrons. So what are some important key concepts to know? Well, we got our gravitational force here, right? Force due to gravity, negative mass times acceleration due to gravity, and that means it's always going to act in the negative y direction, which is important to know. Our electric force, we got electric force is 1 over 4 pi epsilon naught times the source charge, the charge it's acting on, distance between the two squared, and our unit vector r hat, which is going to point from the source charge to the observation point. And the magnitude can be found here. Our last one, arguably the most important one, we got the acceleration of an object is equal to the net force over the mass of that object. So it's really important to know in static equilibrium, when the acceleration is 0, net force acting on the object is also 0. Some important assumptions we had to make here. Well, air resistance is assumed to be negligible because it's really small and just be really annoying to deal with. Treating all charged tapes as a single point charge at the center of the tape makes it easier to model and compute the charge of each tape, as well as assuming both tapes have an equal amount of charge. Again, modeling, computing a lot easier. So some lab procedures here. Well, you see in figure 2 how we created the charge tape. Put that U-tape on the base tape, rip that bad boy off, we got a charge tape because it strips the U-tape of electrons. And now we have our interactions between our hands in the U-tape. We have our pen rub through hair in the U-tape. We also have the interactions between the U-tapes together. Saw what happens. Suspended one. Some observations we made here. U-tape was attracted to the hand and the pen. Pen was rubbed through the hair. We know the pen is negatively charged, which means the U-tape is positively charged. And because the two repelled each other, we know the separation distance was due because they were both positively charged, and the separation distance was 0.27 meters. So the environment we have here, right? Our system includes the suspended U-tape, and our surroundings include the held U-tape and our big fat planet Earth. So our acceleration due to gravity is seen here. Due to the Earth, our electric force due to this charge here is seen up here, pointing upwards. We know because the system is in static equilibrium that the acceleration is 0, which also means the net force is 0. This is really important, which means that the electric force is equal to the magnitude of the gravitational force. So how does this help us? Well, we can use a computational model to do a lot of good calculations for us. We got our constants here. We got electron charge, K constant, acceleration due to gravity, tape dimensions, atom length, distance, and our force calculations here, gravitational force, electric force is just going to be the opposite of that. We got our charge calculations, our R vector, our charge due to the electric force, and our R vector. We got our number of electrons thanks to the charge, number of atoms, ratio of atoms to electrons. And our visualization here, we got our held tape right here. We got our suspended tape, electric force, gravitational force. Magnitude of both of those forces are equal. Charge on the tapes, deficiency in electrons on each tape, and number of atoms per electron in each tape. So similarities, differences. Model assumes there's no outside forces on our system, which is not true. The model also assumes strips of tape as point charges when really it's distributed across the surface of the tape. Model assumes perfect experimental technique. Knowing me, definitely not true at all. In reality, procedures could be repeated, produce different results every time. And similar to the two, though, the gravitational force is always negative y direction. Electric force is always pointing upwards on the floating tape. Sources of error, we got inaccurate measurements, air resistance, we got magnitudes of charges could be different due to mishandling, and the tapes are not actually point charges, so holding them non-parallelly, which may be a word, could lead to different separation distances. So discussion here, right? What if electrons had positive charge and protons had negative charge? What would that change about our observations and just in general? Well, the electric field produced by an electron would point outwards, one produced by a proton would point inwards. Nothing would change about our observations, though, because the tapes and other charged objects would interact the same. like charges still repel each other, opposite charges still are attracted to each other. And it is also really important to handle the charge tapes with like as little as possible, right? We know electrons can be transferred from source to other objects. Transferring electrons from our hands to the tape would decrease its charge and decrease the repulsive behavior. In conclusion, both tapes are positively charged, repelled each other. System was at static equilibrium. Electric and gravitational forces were equal, and assumptions had to be made in order to make the model more practical.